Bruh. Hello, everyone. Yeah, streaming works better if I remember to uncover my webcam. Oh. So, how is everyone? I hope everyone has a great Wednesday. It's currently having, or has had, at the very least. So today I'm gonna do a short stream, probably just an hour and a half tops, because I have to jump on train, because this evening is beer o'clock. We are holding like an emergency London beers for GNOME to celebrate their GNOME 42 release, but mostly because former Londoner that used to live just around London is visiting. So you might know him as the maintainer of Frogger, which is the small utility that shows and uploads your photos on Flickr. Is Mario Sanchez, and he used to work with me at Endless, and now he's working at Galia, and is visiting London because he misses it. I'm actually like 80% convinced that he's visiting just because he ran out of Kendall mint cakes, so he's making a little bit of a like building a little bit of cash there. Yeah, so it's gonna be a short stream today. Yes, I didn't do anything. I swear, I'm honest. I didn't do anything. Hi, Georges, by the way. Yeah, it did that entirely of his own volition. I didn't do anything with mint cakes. Oh, the cake was already there. Yeah, it's always there. It's always available. Oh. So I'm actually happy that a lot of people have had I've tried out Amberol in the past couple of days. I'm pretty happy that people are enjoying it. They're having fun with all the limitations that the application has, considering that it's an alpha build of something that I coded up in essentially a week of real time. So I'm pretty surprised that people are looking for a Winamp clone in 2022 instead of using their music collection managers. Yeah, I've already started receiving like merge requests and of course issues because the amount of bugs that are still left in there is staggering, to say the least. But I'm pretty happy with it. I did a 0.21 release, but it's still I'm probably going to do a 0.3 at this point. I don't know. Yeah, I'm adding stuff. So 0.3, it's gonna land on Friday probably. I'll try and do it on stream again, since people enjoyed that. Yeah, the feedback has been good. I'm happy with it. Again, it's an alpha quality application that it's basically, yeah. It took me, so I started it on the 10th of March. I like spent a couple of days setting up the project and doing like the minimal stuff there, and then between the 28th and the like 3rd of April, the 2nd of April, I coded the rest. So it's, yeah, a little bit over a week, like 10 days. So I'm happy with. It's interesting that, so the joke that I used to make was that, of course, everyone is writing media players for GNOME. You can get a reasonable approximation of a media player in less than a week. That's why everyone does it. And it turns out that I was actually correct. It takes about a week, especially if you're not also learning the how GTK and how the language bindings for a specific language actually work. So yeah, it's about 10 days to get a decent approximation. I was right. That's why nobody writes text editors anymore. Everyone writes media players. There used to be a time when people were writing window managers and then text editors and then like display servers. Now that we have Wayland, music players, they had their heyday when GStreamer usually does a massive new release. So as usual stuff. It's interesting that the there we go, and there we go. It's interesting that even on Twitch they do like create a user like years in advance and then just run it at some point. That's interesting. That's an interesting tactic. They use it, they do it elsewhere, but also Twitch is subject to that. Anyway, since I'm here, let's just go over the couple of changes that happened since Monday. Wow, since Monday. Like in 2 days, we've done a ton of stuff. So what happened in like 2 days? A bunch of cleanups, of course. I had to fix a typo in the application data description because typos are always there. They always happen. So what else? I added, I merged a couple of merge requests, as I was saying. Jakub was kind enough to go over a little bit of the style and fixed a couple of things there. Mostly the title styling, the album art shadow, because of course. Then I did a 0.1 release, also because that one Right. So 0.20 was released with a little bit of a bug. If the song didn't have any metadata, then we would panic because we bound the properties of the song directly to the QRO widget inside the playlist, which is good because the update is fine, but the QRO widget expects that you're always getting a string out of it, out of the properties, whereas the song properties might return none, which is basically null. So it's essentially just a null check. In this case, I fixed it by returning pre-computed string, so we show something instead of showing absolutely nothing. I mean, the type system is good and all, but since a lot of stuff that we are doing happens at runtime, it's basically like running with assertions enabled in like in C, which is a choice. It's probably better than just doing segmentation fault, but this is pretty much the equivalent of that. We are asking the system, give me some data of a specific type, and if that's not the type of data that we're getting, then bail out. In this case, bailing out was literally panicking, so an assertion failure. Then I had a couple of merge requests of Rust cleanup, which is great because again, I'm not a Rust expert, so I'm not used entirely to the idiomatic way of doing stuff in Rust. This time by Christopher Davis and by Bilal, who submitted a couple of merge requests that are absolutely great. I actually had to do a fix that was very... It wasn't a bug entirely of my own doing. I should have known better, but I honestly didn't check. So let's launch Amberol here. And see. Yeah, it's building it. It's taking a while. Right. So let me add a folder. Then we add here. Okay. So you might have noticed that the color is different now, especially compared to the screenshots here and there. But the colors are slightly different because I realized that we were reading the memory wrong. So let's just go inside the utilities function here, the utilities model. So the problem with loading the palette out of the texture data that we have here is that we are literally just grabbing the memory out of the texture data, out of the texture object, and just filling a vector there. The size is fine, but the color format, so the way the pixels are packed into each other, is not independent of the architecture or in general, the endianness of the system. I should have known this because this is API that I didn't write it, but at least I know it. It's inside GTK. I was looking at the documentation. Documentation says it, but in an unclear way, or at least in a way that is not entirely well defined. I'll have to fix it in the documentation itself. But basically what happens is we are packing this stuff in the same format as Cairo. Cairo uses Cairo format ARGB32, which means you have a pixel is a 32-bit wide type, so usually a machine unsigned integer, and the order in which every channel is packed is A, R, G, and B. So alpha channel, red, green, and blue. This packing, though, is not, you have to read the Cairo documentation to understand that, but the packing order is not independent of endianness. If you are on big endian, so on little endian, so x86 and whatever else, the actual packing order is reverse. So it's blue, green, red, and alpha, so BGRA. Whereas on big endian is ARGB, so alpha, red, green, and blue. This means that the getPalette function that we are calling here has to receive a color format that depends on the endianness of the target. In GTK, you would be able to have a symbol, a preprocessor symbol that is defined depending on the endianness of the target itself. So you always use GTK memory format, and the GTK memory format will be the exact packing order as you expect on your system. That symbol is not available over introspection because it's a complex macro. It's also architecture dependent, so introspection just goes, I don't know what to do with it. Which means that you have to understand how that works yourself. In this case, the way I solved it was to use the conditional compilation of feature in Rust and basically check if the target endian is big or little and return the actual color format that the getPalette function expects, and basically checking returning the packing order, like depending on the endianness. Once we do that, the color palette is actually ordered correctly. Oh, hi Andre. Oh my god, I am featured in Baby Wogue. Oh my god. Okay, yeah. I knew that would happen. I didn't know. I didn't know it would happen this soon, but apparently it happened. Okay, praised. Well. Okay. But yeah, that was a doozy. That was something that bug should have been fixed already, but I basically fucked it up. And the fact is, I noticed that would happen, and so I started playing around with the color format enumeration here, but I couldn't get it to run correctly. And then I realized, oh no, it's endian dependent. I need to do like a bunch of this little dance here. But yeah, that worked. It would have been interesting to get like an actual API, like GTK memory texture format, and return the right thing, so I could do a simple match here. But yeah, whatever, it's fine. Yeah, that was a bug that should have been fixed a long time ago, and I didn't notice. What else? Oh yeah, one of the things that so I appreciate a lot of things about Rust, but the two biggest things that I appreciate are well, the two things I appreciate the most are the fact that there is a consistent and mandated coding style. So every single Rust project uses the same coding style, which means that you don't have to care about that, about the project's coding style. But also it's machine like parsable and can be handled by a machine, which is done through cargo format and Rust format. And it's great because it eliminates one of the, it's not the number one issue, but it's one of the biggest issues of when contributing to a project, is figuring out the coding style. A bunch of projects have the coding style written down. A bunch of projects have linters that will like fix the coding style for you, or at the very least deal with it. But the main roadblock is getting into using the specific coding style for a specific project and then leaving it there, so when you contribute to another project with another coding style, you don't unnecessarily mess up your finger memory. Rust doesn't have the problem. There is a formatted tool. Every single project has its own, identical coding style. That's great. So that's one thing. But another thing that I really enjoy about Rust, and it's an interesting thing, is that there is a tool that is called Clippy that will go over your code, basically compile the abstract syntax tree of your code, and then go over it and figure out this bit could be done better, or you're using too many like indirections, or you're using like you're cloning or borrowing needlessly. You can just pass the value there. So not syntax errors, and not even coding style errors, but simplification of your code base. And it's great because it teaches you the idiomatic way of doing things without having to crack open a book. But the other thing is that it fixes your code to be, you can run it on your code to fix it, in like going over it, and it's great. Again, it's a great way to learn the language and how to use it in the most efficient way possible. It's not infallible, but it's good enough to be part of your set of tools. So you run it over your code base whenever you like need it, or whenever you've done a larger factoring or landed a large change, and then it will figure out how to make it, like how to make your code base slightly nicer, or not make a mess. So that is a great thing that removes a lot of the human error from the equation here. So I've run it on Amberol, and I was actually surprised that it was not as bad as it looked. So I managed to not write C code in Rust, which is great. Yeah, there are a couple of other changes that I've done. Yeah, this one happened today, so I'm going to. So one of the things that you can use the GTK API and the GObject API in general with the stuff that is already provided, but in some cases you will have to write your own widgets and your own objects. We have already done it with the Q-row here, which is a custom widget that uses it's a custom composite widget. So it's a simple widget that contains the an icon here and two labels in a box. So we build it inside a custom widget so that the list view here can create an instance and then rebind the fields using the contents of the playlist model. But there are other changes that you have to do, or you have to perform, that are not just building a composite a composite widget, like again the Q row or the entire window. The entire window is a subclass of Adwaita window, but with a bunch of widgets inside it. So in some cases you have to change the behavior of a widget, or at the very least change the way a widget is change out the way a widget works. And in GTK4 we try to steer you towards not doing that, using deriving like widgets. A lot of our widgets are final, so they cannot be derived any further. It's intentional for two reasons. The first one is we can, for future proofing, we can always take a final type and make it derivable without breaking compatibility. But the other reason is that deriving a type will prevent the toolkit developers from ever changing the internals of the type. It's without breaking like external code that we have no control over. In some cases it's easy, in some cases we don't have to do that. We can change the internals without breaking anything, because the type is not just self-contained, but it's entirely expected that you will implement your own behavior inside it. Like basic types like window. A window is derivable not only because GTK has internally a couple of window derived types, but also because it doesn't do anything. You cannot really change the behavior of GTK window. You can only change its appearances. But what if you want to change the actual behavior? For instance, I have a GTK picture here, which is a widget that displays something that can be painted, a paintable implementation, like a texture. And the behavior of this widget is you can define the minimum size of this widget, but if the contents grow above a certain level, a certain threshold, or the ratio is different, then it will try to grow the widget. So you cannot limit it to a specific size, which was one of the bugs in Amberol. So if you loaded cover art that is square, and most cover art are square, then everything is fine. It will be fixed at 128 pixels by 128 pixels, and yeah, that's fine. But if you open up a cover art that is non-square, so has like it's like a widescreen or something that has been downloaded from YouTube. The cover art might be like a non-square, not a square ratio. It will have a higher than 1 or lower than 1 ratio between width and height. In that case, the size of the picture will reflect that ratio. But you could say, okay, I want the picture to not respect the aspect ratio. That is fine, but in that case it will stretch the contents. So you will get a square here, but the contents will be stretched to fit this area here. So what if you want to maintain the ratio, but you want to also fix the size of the cover art? In that case, you will have to use a custom widget that draws the content and specifies the size of the widget itself. So how do we do it? We derived from GTK widget. We cannot derive from a GTK picture. Deriving from a GTK picture would require changing how GTK picture works. And apart from that, GTK picture is a final widget because it's a leaf class. So you cannot derive from that. So we just derive from GTK widget, which is like deriving from any other object. We derive it from it. We don't need all the complications. We always know what we are going to get inside the cover picture. So we only have one field that is the cover, which is a GDK texture. In this case, it's an option. I could use one cell. No, I cannot use one cell, but it's fine. And then we set our stuff here, and we create a property and to set and get the cover texture. And this is pretty standard fare now. We've seen it all over the code base of Amberol. Now comes the widget part. So the first thing we do is we know the size of the cover art. The cover art will not change size, but also will be constant on both axes. Typically, GTK widgets are their geometry is either height for width or width for height, which means that one of the directions depends on the opposite direction. So if you have a label and you specify a size like a width, and the label wraps, then you want the height to be dependent on the width. So if it's the more the label is wide, the less the label is high, and vice versa. The less the label is wide, the more the label is high. So the height depends on the width of the label. In this case, we know that both dimensions are completely constant and do not depend on one another. The size is always going to be 128 pixels. So we change the request mode here to always return a constant size. And then when we are asked to measure ourselves, so when the parent widget asks how big are you going to be, we always return 128 as the minimum size and our preferred size, and we don't have any baseline alignment, so -1 and -1. These two are the only things that are needed to say this widget has a constant size and in both directions, and it doesn't change. So it's actually pretty simple there. If you're writing your application, like you're writing an application that is like a game, and you want to have every part of the board to be a widget, which in GTK4 you should. This is how you make a constant piece on the board, for instance. And after that, what we are going to do is just render the cover, with the caveat that we still want to maintain the aspect ratio of the texture. So we determine the intrinsic aspect ratio of the cover art that we have here, and then we determine the ratio of the widget. That is always going to be 1, but again, it's for convenience. We're not gonna, like, we could remove everything and just make it if ratio is higher than 1, and it's exactly the same. So if the ratio is higher than 1, then the width stay the same, but the height gets cut by the ratio, and otherwise we do the opposite. we determine the offset of the content, so we can reposition. For instance, if the let me give you an example here. So let me check. Right, yeah, this one. So here we have right, we have an image that is wider than its higher, so it has a has a ratio that is different from 1. So we have to change the Y here, so we center this image inside the area that we have here. And in order to do that, we simply go through this and we divide the offset by 2. So we add a translation transformation for the contents. Then we ask the cover to snapshot itself. GDK texture is a GDK paintable, so it's something that knows how to paint itself, which means we have to ask it to paint itself using the snapshot that we get passed inside the snapshot virtual function. This is how, incidentally, any GTK widget works internally. It just snapshots itself, its contents, using the snapshot API. In this case, the paintable here will just append a texture node into the render graph tree, and then GTK will do it. Will do everything behind the scenes to submit all the commands to the GPU when it's needed. So this is all the logic there is. We just want this UI element to be fixed in size, 128 pixels by 128 pixels, and the contents will have to be squeezed into it. And if it's not a rectangular like texture, then we center it within this area here, and that's it. Yeah, the overall idea is that the overall idea behind GTK4 and the widgets in GTK4 is exactly that. Whenever you need something, whenever you need to change the behavior or something, then you should very likely create your own widget. It's easier to do that these days because we have a ton more of functionality that is available for people to use it. Instead of being overly verbose and underdocumented, creating a new widget and packing stuff into it is super simple. The rendering API is not at all complicated anymore. It's just a bunch of rendering operations there attached to a tree of, and yeah, a lot of people tended to, especially in GTK3, tended to take existing widgets and then overriding a bunch of functionality inside that to change the way they behave, and that usually made a mess in terms of toolkit management and toolkit maintenance. And which is why we decided let's not allow that anymore. Because if we make it easier for us to break third-party code, it's not great. It's not great for anybody involved. We break stuff that is currently working, maybe because of some undefined behavior or undocumented behavior, and then we have to fix bugs. And if by fixing a bug we break other applications, then it becomes a mess. So if we prevent a venue of breakage, like a way for people to exploit underdocumented or undefined behavior, then it's better for everyone involved. Hi, you kids. So. Right. So this is actually some thing that I've done. Yeah, what was that, like 3 hours ago? Mostly, I've done it off stream because I wanted to check a couple of things first, but and yeah, so one of the things I wanted to try and make was the ability to shuffle songs in Amberol. So you have a playlist that you want to shuffle it, and the original idea was we have 2 entry points inside the queue API, inside the queue object that we use it for like playback. Is like next song and previous song. So next song goes into the model, well, the store that we use to store all the songs in the playlist, and decides, okay, I'm going to get the next one. If we are in the normal repeat mode, otherwise I will return the exact same song if we are in repeat 1, or if we are in repeat all, then we return either the next song or the first one. So my original idea was, okay, let's pre-compute all the shuffle like vector. So whenever we start playing in shuffle mode, we compute all the indices in like random order, and then we just iterate over that. And that kind of works for like playback, but it doesn't really work for the presentation of the playlist. So inside the playlist we have all the songs in order here, right? But if we want to add a shuffle button and press it, then we want the playlist to basically just change the order, to display what is coming next inside the shuffled order. And if we want to do that, then we need a list model. Since this widget here is a list view, we need a list model that shows everything shuffled. And if we want to do that, then we need to create a shuffle list model. I already like started the skeleton of it. So what a shuffle model is a list model that wraps another list model. GTK4 has a ton of this kind of API. Let me see if I can get the here. No, not this. Here. So yeah, GTK4 has a ton of list models. Has a map list model, a sort list model, a tree list model. There's a slice, a filter, flatten. All these models here add behavior in terms of add behavior on top of existing list models by wrapping them and doing things. Like, for instance, a map list model is a list model that will map the contents of a list model to another type. So a list model can contain only one type of data. But sometimes you want to augment it, and you want to display the augmented contents. Then use a map list model. Every time you get value from the original list model, you take it and you apply a function that will turn that into another object that will be added to the map list model. Sorting is exactly the same, but it will sort the contents of the model by running a comparison function. A tree list model is a list model of other list models, so it will display a tree. A filter is like a sort list model. It will apply a filter to decide whether or not the row inside the list model is visible. It's all wrappers upon wrappers upon wrappers, and it's kind of a common pattern now in GTK4. So a shuffle list model is essentially precisely that. It's a list model that takes another list model, and if nothing else, it will just proxy all the virtual functions from the outer list model to the internal one. So the item type, the number of items, or retrieve the item. But of course, if we have a shuffle list model, the actual implementation would require us to pre-compute the shuffle vector. So a vector of indices that go from 0 to the number of elements inside the original list model. We shuffle them, and then whenever we return something, we map the position inside the, for instance here, we map the position that we get passed to the position inside the vector, the shuffle vector, and at which point we get the shuffled position inside the model. So the way that it would be implemented, first of all, we need to get the RNG crate. Let's see if I added that. No, it's not here. Oh yeah, I should not start stuff and then restore from. Okay, so we go back inside the shuffle model here, and we do use and prelude here. So we're going to need the rand crate, because that's the way that we deal with the random number generator in Rust. So and then we will add inside the model shuffle. This is going to be it's going to be mutable internally, so we're going to go for an option inside the ref cell. So it's back U32, because it's a vector of indices, and indices in list model are unsigned 32-bit. values. We pack inside an option because this might be none. And we use refcell for interior mutability, since this is a G object. And then we add an explicit public function, reshuffle. So how do we, well, we have to generate a vector of the shuffle vector. So the shuffle vector is pretty easy. We start with a shuffle vector here. We know that it's U32, and we do it like sorry. So since the model is here, so if the model is set, otherwise the shuffle vector is none. Okay. We'll probably need, yeah, this actually. There you go. So we are packing this inside a ref cell here. So we have to, like we did here, we borrow a reference from the model, but we also want to dereference the fact that it's inside a ref cell. So we have to dereference the option from the ref cell, and then we use if let model here. And since we know it's a reference, we use the ref keyword here. So this one is going to be a vec of no. It'd be a lot easier if I didn't forget how to do stuff. Where are you? There's a reason why I put code here. Oh, there we go. So, yeah. It's going to be model and items collect. So what we're doing here is we are creating a shuffle vector that goes from 0, well, in this case we're creating a vector that goes from 0 to the number of items inside the model. The number of items is excluded, so it's not a closed set, but it's an open range. And then we collect them all. This one generates an iterator basically, and we call it to collect it, so that we get our vector, our base vector. Then we create our thread random number generator. This one is incorrect. It's going to be shuffle. We can even call it, well, no, let's call it shuffle, even though shuffle is could be better. It could be better named. We could call it positions, yeah. And then we save it inside the otherwise So every time we invoke the reshuffle method on the shuffle list model, then we regenerate the shuffle vector here and we replace it. Yeah, that was dumb. What happened here? Yeah. Oh yeah, it's not self-model, but it's self-model. Interesting. Okay. Yeah, of course. And this one needs to be changed as well. Let's stop also the currently running process. That's fine. Okay, so that seems to have worked. We're not doing anything right now, but we could add this. So we print out the shuffle vector here whenever we call shuffle. And again, we are not modifying anything right now. We're just pre-computing the shuffle vector here. So how do we use it? In order to use it, we will need to add a shuffle button. So we go to the center box, which contains the control box. And we add, okay, so we have the playlist. Let me see. So to maintain a little bit of symmetry here, we should add a shuffle button either here or here. Because otherwise we would have to add it here near the repeat mode, and I don't like that. I like a little bit of symmetry. So this one shows the playlist, so it's an action button like the menu here, so we are gonna add it in between the two. So we are gonna add it here. Child, and it's going to be object class button IP shuffle. The property name is going to be icon name, and we're going to need an icon there. This is the action name, which is the action that will be invoked when we press the button. So you shuffle. And then property name, multi-text, translatable, yes. Shuffle. What are they doing? Shuffle. The playlist. Style. And we want circular. Okay. So the icon name, we are going to need icon library. Let's see what it appears. Okay, so shuffle. It's a pre-installed icon. We want to use the system icon. We copy the name and we copy it here. Media playlist shuffle symbolic. Okay, we added the button here. We need to modify the window so that we can deal with that. We added in the same I added all the stuff here in the same order in which it's defined inside the UI file. It's not necessary. So okay, and then we have to install an action here. It's going to be class install action view shuffle. Bug window. Okay, so I mean, in the future, it's not going to be a GTK button. It's going to be a GTK toggle button. It's going to be a GTK toggle button because sometimes you want to shuffle, but sometimes you don't want the shuffle to apply anymore. So we are going to use the state of the button itself. But right now, it's fine. It doesn't really matter. Since it doesn't do anything except print out the shuffle vector right now, we can live with a button. And we will need a toggle. It's gonna be, yeah. And it doesn't do anything right now. Let's make it here and see what happens. Okay, so we run it. Yep, and we see a new button here that shuffles the playlist. Okay, and doesn't do anything. It only prints out the debugging note here, like window queue shuffle. Okay, so we want to call shuffle on the queue, which is part of the player. So, yeah, so we are going to do in player queue. Oh, yeah, here. So we'll have to add a method on the queue here. And we call it, how do you call it? Set shuffle. And then we do self in model reshuffle. Yeah, for the time being, we call it unconditionally. In the future, we're going to do set shuffle Boolean value here, and then we do reshuffle if shuffle is true and unshuffle if shuffle is false. we already have, so I already have changed the queue to create a shuffle list model that wraps the list or the original list store here. We need both of them because the way things work is we have a model, we have the store, which is the list store here, which is the original storage. And whenever we add a song, we add it to the internal storage. But whenever we want to view the contents of the queue, we query the model, which is the shuffle model. Shuffle model is probably not accurate. It's like shuffleable module, but shuffleable module sounds like an insult or something. So yeah. But yeah, we're gonna reshuffle the model here. So set shuffle. We're going back to the window and we call set shuffle. Again, this is unconditional right now. It will be conditional on the state of the toggle button. So if the toggle button is toggled, we shuffle, otherwise we unshuffle. So we run it. And if we press it here, yeah, the new shuffle vector is empty because there's nothing there. But if we add a folder like this, right? So we added a bunch of songs here and we have a queue full of those. And we press the shuffle here, then we get a new shuffle vector here. So we'll get to the third song first, then we get the first song, the sixth song, the fifth song, the second song, and the fourth song. So that's great. It means this is actually working. Now we need to modify the UI to reflect that change. And how do we do it? Well, we modify the item here. So if we have a model here, we might also have a shuffle. Okay, so we do this. So the item virtual function here, virtual function in C, it's like a trait function in Rust, asks us to return the item at the given position. So the default of this implementation is just proxying the same method to the internal model that we are wrapping around. But if we have a shuffle vector, if we don't have it, we return exactly the same thing. And this is going to be useful later on because the unshuffle method is going to be just remove the contents of the shuffle vector. Just delete the shuffle vector. Here we are going to do this. So return model item and then shuffle get position. It's probably gonna barf in my face because I never remember the get. We can double check that. Let me see here. Rust std vec get. Yeah, of course it's not there here. Get returns an option. Okay, so we do get change that. Fudge. What are you doing? Okay. Okay, so right. So let's add a few add a folder there. And then we press shuffle and it didn't change anything. Why didn't you change? Oh yes, I know why it didn't change. Because I forgot one important thing. We need to emit the model change, the item change. So it's one thing that we also do here. So we need to emit the items changed or the change function, the change signal on the model itself. Otherwise, the anything that is connected to the model, like the list view, displays the contents of the model, will not know that it has to be rebound completely. In order to do that, though, I want to double check one thing. So it's going to be docs gdk4 no PIO class list model. It's not class, it's an interface. So yeah, items changed here. So yeah, we are going to have to do something like this. Self items changed from 0. We removed all of them and we added all of them. So it's going to be it's going to be model and items model. It's okay. Why is it not doing anything? Oh, I know why. Because I'm a dum-dum again. It's going to be here. Exactly. I knew something was wrong there. Yeah, it's the same thing. We have to do this again. Yep. Okay, yeah. Me to dereference. And of course, this will let's use some of these. So this should change also the appearances of the entire thing. So if we add folder here, like, okay, this is the order inside the folder. If we shuffle the playlist, yes. If we shuffle it again, that's correct. And that's correct again. Perfect. That was a lot less painful than I expected. Okay. So, yeah, this is great. Okay, so we reshuffle here. We remove the debug here. Okay. So, now we have to modify the UI so that it does the right thing. We use a GTK toggle button instead for the shuffle button, and we have to go back all the way back. Shuffle button is going to be a toggle button. So let's see. This is gonna be funny. I don't remember if it's correct, if it does the right thing. So let's see. Native equals in shuffle button live. And then we go back inside the queue, and then if shuffle here is model unshuffle, and then we have to add an unshuffle method. That does no, we just need to do self in shuffle replace with none, and then no, we need to access the model. And self items change 0 model and items. Okay, that should work. I'm more interested in whether or not the action is going to be stateful or not, because I'm using the widget actions there, but I don't. I need to double check if that works. What the heck? Toggle button. The fudge? I need to. I should not be guessing the API. So toggle button, yeah, is active. The problem with Rust, the Rust bindings, is that in order to be more idiomatic, the API is changed compared to the C API. The C API has a get property name and set property name. In Rust is set property name and then property name for the get function. And I remember that I have to remove get, but I have to remember that also I need to check if that is the correct version, the correct name of the property. So let's add a folder here. Okay. Yeah, because it's the action is stateful at this point because it's toggling stuff. So I will need to toggle that. But I don't remember how to do it. I don't remember how to do it with this kind of API. Okay, so Q shuffle. Because I might need to add an actual action, a stateful action here. Let me see. Because I'm pretty sure there are other Rust applications that do this. Let me check inside my I'm pretty sure I've seen other stuff like this. So let me go to an actual terminal. Right. No. Let me go back here and then open a terminal. There we go. So let's see if shortwave has a toggle button. There is a toggle button, and it's also inside the window. Nice. Okay. So, because the way I would normally do this is I connect to the I wouldn't use an action in this case. I would use a direct connection to the toggle button. Like this. So I would use an actual connection here, an actual signal connection, and not an action, which is fine. Yeah, we can do that, and then I'll try and figure out how to do it with an actual action instead. Action are nicer, but when it comes to stateful, to an action with a state attached to it, it gets a little bit wonky, and the API, I'm not entirely sure the API is the same. Let me see. Install action. Yeah, I don't need a parameter type. I need the state, and I don't remember how to deal with the state in this case. I have to double check the C API and then translate the C API into Rust. Yeah. Let's keep it simpler. So we are going to go here. We remove the action here. And then inside connect signals. Where are you? Here. So yeah. So shuffle button. Connect. Toggled. And we do clone. Do we need no, we can use a weak. We don't need an actual strong. reference here because we know it will always exist. So we do let you is going to be win in layer view, and then we're going to do if let's call it with a different name, shall we? You set, well, we can do you set shuffle. Simple that way. There you go. We need to delete this as well. No, I didn't want to do this. Let's try it then. And let's see what happens there. So let's add a folder to populate our playlist, and then we press it. Yep. And then we unpress it. And yep. Now we have shuffle. Good. Well, that was fun. And right on cue as well, because now we have to, I'll have to finish the stream. Okay, so okay, status git switch, let's call it shuffling. So cargo tunnel and cargo lock. Add a brand to the list list of grades. Of course. What the fudge am I doing? So, good. We need to add shuffle here, and then we are going to add the mod and audio cue. Okay. And yeah. Okay. This should be enough as a first commit. Okay. Oh. This model is a wrapper model that takes a GIO list model and presents its content using a shuffle vector. Okay. And shuffle. Button. Does what it says on the thing. Let me also add this little picture ratio is a constant. There's no need to compute it every and yeah, we're going to also need to update the changes file, the changelog file, but that can wait. So before we do this, which is something I always forget to do, yep, I need to do a little bit of coding style fixes. Shuffle this model. Where are you? So we'll have to go to the new constructor here. We don't need to do all of this. Okay, we just need this. Okay, and model connected items changed. We have to instead do this. And this. And then on window, line 492, very end of the connect signal 492. We need to add here. There we go. So we'll need to modify the history here a little bit. Couple this model. There we go. And then the window. Close these two. Let's fetch the current state of the. Okay. Rebase origin main. Auto squash. Right. Off. Okay. Okay, new merge request. Now we go into the changes and we will add on edit. Shuffling the playlist. I have an issue about that. Start shuffling the playlist. 5. There you go. We will also need to go on the merge request. Edit. There we go. Oh, that was fun. And a lot less complicated than I expected, honestly. Yeah, the only complication I had was the toggle button. So toggle buttons are in using the action, like the action model. The actions come with a state. So you have like, yeah, you have a Boolean state, and you have to flip between the two. Usually, when you're dealing with a simple toggle action, a simple toggle button using an action, it's easy. You create an action that has that is stateful, and then you connect to the activate signal on that, and you save the state by toggling the current state. So you modify the model there, and that is again pretty easy to do if you're installing the action yourself. If you go through the action API onto inside the GTK widget class, it gets a little bit more complicated. I'd have to double check because I've never used it. I usually use either actions that are stateless and unparameterized, or I use a stateless action with a parameter. Actions with a state are not that common for me, so I'll have to double check how it works. Yeah, the most complicated bit was figuring out that you have to create a model there that wraps your own model, and then that applies the shuffling bit on top of that, which is not complicated at all. But once you have the shuffling bit done, it automatically allows you to display the shuffled playlist in your inside the playlist itself, which is always a plus. Otherwise, you'd have to rearrange the list model, just resort it differently, or do some weird. You cannot resort it differently because sorting implies a comparison function, and you're not comparing anything. You're changing the way an index is mapped to an actual object, and in this case it's a lot easier to figure this out. You pre-compute all the position there, and it's done. There is a thing that I didn't add, and it's bad. Yeah, I'd have to reshuffle the contents of the model when we add new stuff or remove new stuff, because then the shuffle vector does not match the size of the model. So whenever we add something to it, and which means basically calling, like reshuffling here, inside the items changed. Yeah, let's see if I can. Yeah, no. Yeah, no, it's getting way too late. I'll have to leave it to Friday at this point. So, let's go back to my head. But yeah, that was implementing the shuffling of the playlist in Amberol. That was actually pretty fun and not complicated at all. Or at the very least, a lot less complicated than I expected it. I was over engineering a little bit when I thought about changing the way the queue advances to the next song. I was kind of both over engineering and under developing the feature, because if I did that, then I would have still needed a way to figure out how to represent the queue in shuffle mode. And in this case, instead, it's pretty easy, because every time we read the shuffled list model, then we have the actual shuffle order without having to change the way the queue is implemented at all. The queue always iterates incrementally from 0 to the last song. Internally, what that means that we just change the order internal. We just give you a different value for the position. But yeah, that was actually a lot less complicated. And it's also a stable order, so the ordering is exactly the same because it's pre-computed when you shuffle it. So you don't have anything else to deal with. Oh, hi Jeff. Thanks, Georges. Yeah, right on time for me to go and have a pint or 3 at the pub after 2 years of literally not going to the pub. It's terrible. Anyway, so if you enjoyed watching me struggle with Rust and GNOME and GDK and libadwaita, and if you want to have more, then follow me on YouTube. I usually upload the VODs. I have a backlog, I know. I will try to upload them all as soon as possible. Otherwise, you can always follow me on Twitch, twitch.tv/ebasi, where I do this kind of stuff live. I either code in Rust or C or write documentation. In general, I work on the GNOME project on stream. So if you want to know, if you want to follow along, if you want to know how to write application or library or platform code for GNOME, then join. I also have a bot command that people can use. Yay! So again, it's the streaming goes usually Monday, Wednesday, and Friday. The VODs I try to upload them on the following day, so Tuesday, Thursday, and Saturday. But yeah, have a great rest of your Wednesday. I hope you will enjoy as much as I will tonight. drinking beer and chatting with a bunch of other nerds. And I shall see you all on Friday for the last stream of the week, where I will probably just fix a bunch of stuff in Amberol to deal with the shuffling and a bunch of other like buglets that I find here and there, and then do a release that will be available on FlatHub pretty much instantaneously. For everything else, see you on Friday. Have a great rest of the day. Bye.